Great. Okay, thank you all for coming. One of our second to last weather briefings. We're glad to get Elliot to come back later on the semester because I know he was rediscovered earlier. But without further ado, Elliot, Abrams, AccWeather.
Hi, everyone. I'm going to talk first for a little bit about one of the effects of cold. A person bought a parrot for his family for Christmas and placed the parrot in a cage on a table. Now, his kids were about to come home from school in a few minutes. So one was 5, one 8 years old. And the parrot starts cursing. He says, "Shut up." Parrot gets louder. Parrot gets even louder. Well, he's not a cruel person, but he picks up the cage and puts it in the freezer to see what the effect of the chill would be, and takes it back out a minute later. And the parrot's standing there. "I know why you're upset. I cursed. I'm never going to curse again. I'm going to be a great pet for you, the greatest you've ever had. But I have a question." "What's your question?" He said, "What did the turkey do?" It's not that big. Anyway, it's better than the movie that they made later about the haunted turkey, Poltergeist. Talk about the current weather situation. Many may say that it's going to tie some records for boringness over the next few days. We're going to see this endless parade of steel wool clouds scraping across the sullen sky. Those who wish for snow will maybe see a few flakes falling at a rate that if they fell that rate all winter, they might be 1 flake deep. And maybe we get a little covering tomorrow night. But up toward the lakes, it's going to be interesting because at lake level, temperatures at the surface may not get down to freezing, but you get up to 1,000 feet or 1,500 feet, like around Jamestown, New York. Some of those places could pick up at least several inches of snow. There was a band that formed off Lake Erie this morning, very parallel to the lake. And when the when the gradient is parallel to the lake, it's almost like a snow gun pouring the precipitation out straight east-northeast of the lake. And so they may get a fair amount. But this morning, this was the pattern at the surface. Now this millibars here are plotted, I think, every half of a millibar. So you get a lot of detail, and you also can get a lot of errors where there's bad data or no data. For example, there's no data over the ocean, so we don't really know what the gradient looks like there. But this morning, there's a low pressure area east of Maine, and another one farther west, the original low pressure area, that had come up through the Ohio Valley and Great Lakes. And it's a westerly flow. And one thing you can see here is the effect of cold air damming from the west, where you see the pressure is building up against the mountains, and then east of the mountains where the pressure is lower, you see the wind turn to northerly. Similar thing happens with the opposite flow. When we keep the chilly air here in Du Bois or Pittsburgh, might be 75 degrees in the spring and will be 45 degrees, and with dreary, dull, dim skies that are very drudgerous. But in any case, that was the situation this morning, and the storm is slowly moving to the northeast and away, and this high pressure area to the south is building in a little bit. Then, looking at the satellite picture, Okay. Streamer of clouds that a couple of days ago on the picture here was running from Alabama to Pennsylvania has slid eastward and southward. So it's from Florida out into the open ocean now. And the hanging back cloudiness associated with the upper low is back over the Great Lakes as the main low pressure area moves away to the northeast of eastern Canada. We can also see streamers. And if this were in motion, you see streamers coming across the western states through the Great Basin and turning southeastward. A little feature that's trying to cut off in Texas. The model's been having a hard time deciding whether it's going to cut off or continue to move. And each day's runs are different, and the runs are different even between, as we see the spaghetti plots, each different member of a model that make up an ensemble show a different story. And I wanted to illustrate that. My iPad, meanwhile, shows the latest iTunes bug where if something didn't totally download in the last couple of days, it'll come back with a reminder that it didn't fail to download like every 5 seconds, and then it comes back again. But the thing I wanted to show here is with multiple models. This is from the site despair.com, and the caption here is, none of us is as dumb as all of us. So you take these models sometimes and you really are totally confused. If you pick one, you can wind up mongering for some big storm that will wind up not happening, or ignoring some event that might have serious impacts to people. So this morning, it was actually last night, member 1 of the GFS from last night for this coming Sunday evening, Monday morning, showed a high pressure area over Pennsylvania and a small area of snow in northwest Pennsylvania and over Lake Erie, and the storm causing rain in Alabama and Georgia. Now, it's very important down there because they've been in a drought. The only area not really in a severe drought is the area that was doused by Matthew earlier in the fall. Those areas had tremendous rains, but if you weren't affected by Matthew, you virtually had no rain from then until a few days ago. Charlotte had 0.05 of an inch of rain through 2 days ago, and then it picked up some rain on the 29th and 30th. Okay, so that's member 1. Well, I have it labeled wrong, but that's actually Monday morning. Here's member 2 for Monday morning, and this shows an area of snow, probably, that is over central. Now, this is the 6-hour period up till 7 a.m. So at 7 a.m., it's probably not snowing over that whole area if the system is moving. Sometimes if you look at those areas and think, oh, it's a large area of precipitation, it may or may not be, depending on the speed of motion. But it's essentially over at Pittsburgh, or had been for several hours, and is now advancing into New York. The rain in the southeast is a little farther east and a smaller area. We go to member 3. And this has a wider area of rain from Mississippi over to Georgia, and quite heavy rain. But perhaps in response to the upward motion there, there's subsidence up over Pennsylvania, and nothing is happening whatsoever. Same time. Go to member 4, and it has the rain in the southeast isn't as concentrated as far west, but it is along the coast, and you see an area of snow up here in the western Pennsylvania. Central Pennsylvania. Member 9, or you know when, it's the same time, of course that's an excellent label scientifically, but shows the largest area of snow, covering all the way from affecting eastern Ohio over to New Jersey and southern Connecticut, and even a little batch of heavier precipitation has just occurred in northeast Pennsylvania and eastern New York. So what's the right answer? Anyone have any ideas? All right, let me do it this way. How many of you believe that Sunday night or Monday morning it'll snow here? How many don't think it's going to snow here Sunday night or Monday morning? How many don't know? How many don't care? How many will not raise their hands regardless of what the question is? You say, well, you don't. Okay. Well, anyway, we don't really know. And so when we look at deterministic progs out that length of time, okay, they're lines on paper or lines on a screen, but that doesn't mean they're right, and you have to do more analysis before you can figure out what's really going to happen. You can do it probabilistically if you see, say, 5 of the 10 members showing pretty much the same story. You might have more confidence in it than if 1 of the 10 members. But one of the problems with the ensemble means that are then generated is that it does come up with somewhat of a consensus, but that same consensus will almost always miss the outliers. One of the outliers is going to hit. So that's that. Okay, in today's pattern, though, we see the existing high pressure area coming in from the west. There'll be a weak low pressure area that looks like it comes across early next week, and that's this one. And then after that, the model will show a trough deepening in the west central states and a pretty large storm coming up through the Midwest, probably in the middle of next week. And at that point, we see that all the warm, moist air coming up from the Gulf of Mexico. We'll probably see another round of thunderstorms. Hopefully no tornadoes, although that could occur once again. The 3 fatalities in Alabama and then 2 more out of this last day. I think that prompted the large area of tornado watches that issued yesterday morning. But it could happen again. And then that front looks like it sweeps eastward and brings a real chill to our area at the end of next week. The question then is, how long will it last? Looks like several clippers come in the following week, the week after. And with clippers, if you're off by 12 hours or 24 hours on the timing of them, you miss the forecast entirely. You might say it's going to snow or rain on a Thursday. Instead, it happens Wednesday night or Thursday night. The whole thing's wrong. And if that's wrong, then everything that you do subsequently is going to be wrong as well. I also have a forecast for the winter, and that's that I believe that it's going to be getting colder over the next several months. But then, come March and April, we'll see that change. And I wouldn't be surprised if the daffodils come out and then the tulips. And it'll be too early to plant annuals yet, but the lawns will have to be mowed, and eventually we'll have another crop of gnats and mosquitoes. Any questions? Some people ask us why we can justify putting out a 45 or 90-day forecast, and my answer to that is that people are interested in the long range, but anything beyond 4 or 5 days, in my opinion, is more entertainment than real scientific forecasting, even if the pictures look the same. You see this on TV all the time, like the 7th-day icon might be the same size as the 1st-day icon on a TV weather presentation. There's little justification for believing that 7th day has the same likelihood of accuracy as the 1st day. And we could actually use colors or textures or sizes to indicate uncertainty. The ensemble mean product, let me find this, does this to some degree. Just locate it. Down to the GFS songs someplace. Right here. And when I look at these, I like to go to the ensemble mean 6-hour intervals with the heights and thicknesses and precipitation. And that's the ensemble mean and mean sea level pressure, 6-hour precip with 1,500 millibar thickness right there. And add the loop. One of the good things about it is the area where the model seems to be centering on most of the precipitation will show up with greens and darker colors, whereas the other areas are gray areas. And I think that's very appropriate because those are the more uncertain areas or the areas with light precipitation. So here's this storm, for example, and the one for early next week is, I did something wrong with this page, but anyway, you see the gray areas, and those either have light precipitation or only some of the members have anything, and the other members don't. But it's I think it's a nice picture to look at for at least several days out, as far as the model goes. So, any questions so far? Have all of 10 minutes. Wanted to talk briefly about a couple of other things that can be useful in snow forecasting that we don't typically use very often. I find that many of the older forecasters, when you say what's going to happen in Chicago, look at a map, the area around Chicago, and come to an assessment. And when I ask our newer forecasters, and the millennials we have at AccWeather actually are harder workers than some of the ones that came just before. It's really impressive to see how enthusiastic they are, and I think that's because of the education they're getting right here and at some other places, but right here especially. But Um, they'll just look at the model for that model output for that one point. Like the various output statistics, they'll pick Chicago. Won't even, if something's happening at Rockford or across the lake, to the southeast of South Bend, they wouldn't even know it looking at this. That's just a habit we get into when somebody asks you the question, what's going to happen at this point? But it's an interesting commentary. But anyway, so we look at the 1,500 thickness, for example, for snowfall, but does anybody know a more refined thickness that might help us get a rain-snow line? Anyone? There are no wrong answers.
534.
The 534, that's a value. And also the 1,850 thickness is useful. And because the snow versus rain determination is typically in the lowest 5,000 feet, it's always cold at the 500 millibar level. And usually it's 700, but between 0 and 850, most of our changes, 1,000 and at 850, most of the changes occur. And so if you know the average temperature in that column, then you have a pretty good idea whether you're going to get snow or not. And a value of 1,300 meters is often very accurate. The strangest snowfall rule I've ever come across is one I learned, I don't know, it's decades ago. It's called the 200 millibar rule. And what you do is you look at the warmest temperature in the bottom of the 200 millibar trough, because at that level, troughs are warm, the ridges are cold. And then you look at the coldest reading downstream. Draw a line between the 2 points and take the numerical total of difference, like let's say it's minus 42 at the bottom of the trough, minus 62 at the top of the ridge, that's 20 degrees. Divide that in half, and that's the number of inches of snow you're going to get. Now, it sounds like total nonsense because that's the English system versus metric, and I'm not going to get into that debate because people who like the metric system will argue for it every inch of the way, and if you like the inches system, it's not a good metric.
Back in the early 90s in Binghamton, New York, we used to use heat charts from the magic chart. We took into account temperature, moisture, and upward motion. Nothing great about it, but I did the job. Usually nailed it within an inch or two.
Yeah, a lot of these older methods work well, and it's often good to not only look for the accumulation, but when they're going to occur. For example, when you get snow or freezing drizzle at 5 o'clock in the morning, and it just begins then, that makes a tremendous difference for the morning commute because it's dry up to that point. If the crews aren't out ready to put salt down immediately or they haven't pre-treated, that's going to be a very bad rush hour, even if it's only half an inch of snow or a thin veneer of glaze. If they do pre-treatment, that is very helpful at first. But if it snows extremely heavily and you get 4 or 5 inches in a short period of time, it will not be all melted by what's underneath it, and you're sort of driving through cheesecake, driving through that stuff. It can turn on you and become very nasty. So they have to judiciously decide whether they're going to pre-treat or not. Also, the late afternoon rush hour, when we have the solar heating, especially as we get to February and March, you get in your car on a late February day that's 20 degrees outside, it'll sort of feel warm inside at noon. It won't at this time of year, but that's because of the solar radiation effect, and it helps melt the snow on the paved surfaces, and so it can be even 28, 29 degrees or even a little colder in March, and snow won't stick. Whereas at this time of year, you get down to freezing, it's going to stick. And so that's an effect too. But all those little things you figure out when you're dealing with people in consulting. And you also have to be aware that when you're talking to people, they may not really understand what you're talking about. I remember a customer who bought a lightning warning service. And we told them, we're not going to know when the first lightning strike is going to be from a particular thunderstorm. But once we see a pattern, we'll know if it's coming toward you. And that afternoon, we predicted thunderstorms between 4:30 and 6:30 p.m. And we felt good when at 5:30 a thunderstorm hit the observation point at that site. National Weather Service had predicted the same thing. National Weather Service is arguably the best federal agency that we have. But in any case, so 5:30 there was a thunderstorm. So we felt pretty good. The next morning, a person called up and says, are you folks the ones who give us the lightning service? I said, yes. I said, we know we had a lightning storm last night. I said, I know, we predicted thunderstorms and you got one at 5:30. You predicted thunderstorms, but you didn't say nothing about lightning. So never underestimate the possibility. I mean, even our dog was able to, our previous dog was able to know the difference. He got very upset when it started thundering. When he got to be about 10 years old, he actually realized that lightning came before the thunder, and you could see the lightning and all and start cringing right then instead of waiting till there was thunder. So always, when you're briefing somebody or talking about the weather, always be on the lookout for signs that they're not understanding you, because it's our job to give them the information rather than expect them to be educated. I had a professor as a freshman, this is the mid-1960s, Hans Neuberger, and he did a study on whether people understood weather forecasts better at the end of the elementary meteorology course than at the beginning. And he found that there was no relationship there. People didn't seem to understand weather forecasts any better at the end than the beginning. I found the same thing doing my master's thesis in 1971, and I don't know if it's that much different now. But there's plenty of work to do, and you're all getting ready to do it. That about wraps it up.
Any questions?
Yes.
It's great that you highlighted ensembles in today's discussion, and also pointing out some of the limitations of the ensemble mean. It's a lot of work to look through a bunch of postage stamp plots. Do you have any thoughts on maybe how to convey scenarios that are not showing up well in the ensemble mean, but might be important to look at for forecasters, maybe clustering of boundaries or some other ideas?
I think if you see, right, the clustering, for example, like this thing today going through these different ones, most of them showed some snow somewhere near Pennsylvania. So I'd say, okay, if you're going to be traveling Sunday night and Monday, listen to the forecast later in the week is to see if there's really going to be any problem. I can't time it yet, but if only one of 10 members showed it, I'd probably say, okay, it's showing it, but most of them say no. And when most of them say no, most of the time, it doesn't do that. But I think it's very important to use the ensembles rather than just trying to use individual deterministic charts that are shown there, because then you're only seeing one of the members to begin with and not the ensemble. You don't even know what the ensemble mean is. And it's very important work that's being done to try to do this. I was on a committee a few years ago where we tried to assess probabilities and the use of them in forecasting. And at the end came up with the conclusion that much more work was needed to be able to understand them. Many people don't understand even the simple probability of rain, 50%, that's a 50-50 chance of 1/100th of an inch of rain falling in the official rain gauge in a certain set of time. It's not an area, or it doesn't tell you how long it's going to rain or how much. Although all those things can be done probabilistically.
Anything else? All right, thank you very much, Elliot.
And thank you very much.
Next week, we'll have Rich Brown for the last week in the semester.
Good luck with this one.
Thanks.